So welcome to the lecture for chapter 5.6, and today we're going to be looking at half angle identities. We just looked at double angles, so now we're going the other direction. So we can use the cosine double angle identity to derive half angle identities. Here we have cosine of 2x, the double angle, equals 1 minus 2 sine squared x. So if we swap out the 2 sine squared x and the cosine 2x, we get 2 sine squared x equals 1 minus cosine of 2x. We divide both sides by 2 and then take the square root of both sides. We get the sine of x equals plus or minus 1 minus cosine 2x over 2. Well, if we set a equal to 2x, notice what we get here is that if a is equal to 2x, then of course x is a over 2, and we get 1 minus the cosine of a over 2, and that's the plus or minus the square root of that entire quantity. Okay, it's really not important for you to know the derivation of this, but it shows you how from one identity we can derive other identities that may be useful in certain circumstances. And of course, as we've done throughout the entire course, it's important for us to choose the right polarity, the appropriate sign, positive or negative, depending upon the trig function we're working with and the quadrant of the angle. In this case, the angle is a half angle, or a over 2. We can do a similar thing with cosine, and we end up with the cosine of a over 2 is plus or minus the square root of 1 plus cosine a over 2. Again, same thing, choosing the right quadrant based upon where that angle is. If we divide sine by cosine, we can get tangent, and we have a number of ways of doing this. And so we come up with 3 different identities for the tangent of a half angle. Okay. These are all of the identities, the half angle identities for sine, cosine, and tangent. Important to have these in your notes and be able to refer back. So let's look at an example. Use the exact value of cosine 15 degrees. Find the exact value of cosine 15 degrees using the half angle identity for cosine. Exact measures require known angles 30, 45, 60, and quadrantals. So when you're thinking about problems that are looking for the exact value, you have to kind of think in terms of those angles. So in this problem, how can we think of cosine 15 in relation to these? Well, notice that the cosine of 15 degrees is equal to the cosine of 30 degrees divided by 2. And 30 is one of our known angles. Remember that 30, 60, 90 triangle? So if we look at that and now compare it here, we can see that if we make this the cosine of 30 over 2, then we can substitute cosine of 30 here, and we can actually calculate the right value. So the cosine of 15 is equal to the cosine of 30 over 2, which is equal to the square root of 1 plus cosine 30 over 2, which is simply applying the identity. Why did we choose the positive square root? Because we're in quadrant 1, and in quadrant 1, both x and y are positive, so sine and cosine, and in this case, cosine is going to be positive. Now we're just doing algebra. So we get 1 plus the square root of 3 over 2. First, we have a common denominator in the numerator, which is 2 over 2 plus square root of 3 over 2. When you have a fraction over a denominator, that fraction sinks, and so we get 2 plus the square root of 3 over 2 all over 2, which that sinks, and the denominator becomes 4. And the square root of 4 is 2. And so we get this final answer here. This is all algebra at this point and solving complex fractions. Sorry about that. I'm going to pause this for a minute and I can. Okay, this is a similar problem. Again, we're looking for an exact value of tangent 22.5, and they tell us to use this identity. Again, we're trying to think in terms of the known angles, 30, 45, 60, etc. So how can we think of tangent? Well, of course, tangent 22.5 is equal to tangent of 45 over 2. So if we apply this to the identity, that gives us the sine of 45 over 1 plus the cosine of 45. We simply substitute those values in there, and then we use algebra to solve this complex fraction. If you don't know how to solve complex fractions, this is a good thing to go online and maybe go to a Khan Academy, etc., because you will find a lot of these kind of more complex fractions in trigonometry and certainly in calculus later as well. So this whole equation, I'm not going to walk through the steps to simplify a fraction, but this simplifies down into the square root of 2 minus 1. Let's look at a multiple step problem. Here we're given a value of cosine s equals 2 over 3, and that the angle s is in between 3 pi over 2 and 2 pi. That means it's in quadrant 4. Okay. We want to find specifically the cosine of s over 2, the sine of s over 2, and the tangent of s over 2. So one of the things we have to do first is figure out what quadrant is s over 2 in. This is actually really simple. Since we know we have this inequality for the angle s, and we want to know the angle s over 2, we just divide all three pieces by 2. So here we get 3 pi over 2 divided by 2 is the same as 3 pi over 2 times 1/2, or 3 pi over 4. S divided by 2 is s over 2. And then 2 pi divided by 2 is pi. And so we can see that the angle s over 2 is between pi and 3 pi over 4, which is in quadrant 1. So this lets us know that cosine and sine and tangent will all be, I'm sorry, this is between pi and 3 pi over 4. This is in quadrant 2, not quadrant 1. My bad. And so we're in quadrant 2. Cosine is negative. Sine is positive. And tangent will be negative. Okay. So now we can plug in the values for this. We know that the sine of s over 2 uses the cosine of s, and that was a given value, so we simply plug this in, and we get the square root of 6 over 6. Cosine s over 2 also uses the cosine of s, and so we simply plug that value in, and we get negative square root of 30 over 6. And then for the tangent of s over 2, since we already have sine and cosine of s over 2, we can just use the quotient formula, and here we get negative square root of 5 over 5. I'm not walking through the individual steps of plugging these in and simplifying with radicals and fractions. I'm expecting that you already have those skills. Okay. Simplify the expression 1 plus cosine 12x over 2. So here I think it's important to kind of look at the identities, and this actually matches the identity for the cosine of a over 2, where we can see, and I like to write them side by side, so if I try to do this in my head I can get confused, but I can see here I have the right side of the equation where a would be equal to 12x. Okay, so if I want to simplify this expression into just cosine of a over 2, if a equals 12x, then what I have is the cosine of 12x over 2, which is simply the cosine of 6x, and I've solved this problem. I can do the same thing here. Notice that what I have here is the right side of the tangent of a over 2. And here a would be 5 alpha. So what I'm looking for is the tangent of 5 alpha over 2. Okay, I like again to write these out side by side or on top of one another so I can like really figure out what the angles are. Like here a was 12x, here a was 5a or 5 alpha, and then I can manipulate the other side of the equation using that value. All right, let's look at one more thing and then we'll be done for the day, and that is to verify that the sine of x over 2 plus the cosine of x over 2 squared is equal to 1 plus sine x, that this is indeed an identity. Well, when we have problems like this, first of all, the left side is much more complicated, and we have this quantity squared. A good idea is to get rid of parentheses, to get rid of algebraic things going on. So the first thing I'm going to do is square this, and this is a FOIL. So I get sine squared x over 2 plus 2 sine x over 2 cosine x over 2 plus cosine squared x over 2. Again, I'm not going to show the FOIL. You should be able to do this. You should be able to do a simple square using a FOIL or a multiplication table. The next thing I want to do is I want to rearrange this. Why do I want to do that? Because I see a cosine squared and I see a sine squared and a cosine squared, and that's one of the most common identities, sine squared plus cosine squared. And so I can see that, and if I combine those, hopefully you know that identity quickly. But the other thing I want to do is I want to play that game of Go Fish. Okay? I know this identity, sine squared plus cosine squared, as long as the angle is the same, is equal to 1. But I have this other weird part here. Is there another identity that looks like this? Yeah, of course there is. This is the sine of a double angle. Notice that what I have here is the right side of the sine of a double angle. So if the angle is x over 2, then I can substitute in sine of 2 times that angle, x over 2. Okay? And now I have simply 1 plus sine x, which is the right side of the equation. Okay? So here again, we first did the algebra, and then we kind of looked at the equation. I saw sine and cosine squared, so I immediately put those next to each other and just looked at the part that I have left. And then I played my Go Fish game, looking through my list of identities and finding the right one. Okay, hopefully this has helped you with the half-angle identities. Get those identities down, be reviewing them, writing them down is one of the best ways to kind of get them in your mind. And even if you don't have to memorize them for the test, you should be familiar with them so that like you can look, you know, that does look kind of familiar. Let me go check my list and see if I can find an identity with that in it. All right.